One of the most complex issues that you'll need to deal with when contemplating a SQL Server installation is the hardware and software that you're going to run it on. Part of the problem is that the minimum requirements depend on which edition you'll be installing, and, to a lesser extent, how intense your data access load will be from applications. It also depends on whether you'll be running a 32-bit or 64-bit version or an IA64 edition on Titanium processors. The SQL Server technical documentation has the full details about the minimum requirements. You'll want to see the hardware and software requirements for installing SQL Server 2016 topic. In general, you'll want to far exceed the minimums. If the database will have a heavy load from enterprise data and many heavily used websites, you'll want a fast processor, lots of disk space, and a boatload of memory. SQL Server will put them all to good use, I assure you. Several editions of SQL Server will run just fine on Windows Vista 7, 8, and 10. But for a server, you'll want to use the latest version of Windows Server. In general, the latest versions of Windows Server are more secure and more efficient for the kinds of things that SQL Server has to do. SQL Server is a very high-powered server software, so you need to have the top-level Windows Server behind it. You can install either 32 or 64-bit version of SQL Server, but those should match the bitness of Windows where you're going to be installing it. Now you can install SQL Server on Windows Server Core, which is a version of Windows that provides a minimal environment for running specific server roles. This helps reduce maintenance and management requirements, as well as the attack surface for those roles. Basically, there's no user interface, and you're restricted in the SQL Server tools that you can install. This option won't be attractive to many organizations, but for large enterprise installations, particularly if you have server farms, hundreds of servers running SQL Server, it can greatly simplify installation and management while providing a more secure environment. It's not a good idea to install SQL Server on a computer that is also a domain controller, because the overhead of maintaining and replicating the database of network accounts, plus the demands of authenticating user logins, will compete with SQL Server for system resources. In fact, SQL Server should be the only server software installed on a heavily used database server. But if you insist on installing SQL Server on a domain controller, you'll run into a number of limitations. You won't be able to run any services under a local service account. And then, once SQL Server is installed, you won't be able to change the server from a domain member to a domain controller, or vice versa. You'd have to uninstall SQL Server before making that kind of change. And SQL Server won't support failover cluster instances where the nodes are domain controllers. And setup will fail if you try to create security groups or provision service accounts on a read-only domain controller. My advice is to just not even try to install SQL Server on a domain controller. It's not worth the hassle, and I've never encountered a scenario where it would be the right thing to do. Now, the most cost-effective way of optimizing performance on SQL Server is usually to throw some money at hardware. Unfortunately, many companies and organizations make it harder to get approval for hardware expenditures than for consulting. But frankly, doubling the RAM on your server will usually help more than paying a consultant to tune your queries. Now, that doesn't give you license to write sloppy queries that unnecessarily use resources, but assuming that your queries are well designed and use the resources wisely, more RAM is usually more beneficial. Now, realistic RAM requirements for SQL Server, not for the computer itself, but for SQL Server, range from 1 gigabyte to many gigabytes, depending on the usage levels. And then network hardware can be as important for performance as your server hardware. So be sure that you have adequate bandwidth to meet your projected needs. And if you purchase disk drives, consider RAID arrays to add redundancy and thereby increase reliability. And check your disk controller is intended for database usage. Some write caching disk controllers can endanger database integrity. So there's some considerations there when you get into RAID arrays. Now, running SQL Server requires no additional network software. Each of the Microsoft operating systems has the required built-in network software. That's one of the big benefits of Windows, how it's developed over the years, that it has the infrastructure that is there, and SQL Server can take advantage of whatever networking configuration you have configured within your installation of Windows. Now, each instance of SQL Server supports shared memory, other than on failover clusters, named pipes, and TCP/IP. So you have a lot of flexibility in the protocols, the network protocols that you use to communicate with your database server. And now we need to talk a bit about security. The core SQL Server programs run as Windows services. Depending upon the options that you install when you install SQL Server, you may have as many as 10 Windows services that are dedicated to SQL Server. Now, in order to run in Windows, each of these services has to be assigned a Windows user account. The permissions of that assigned account for each service determines the security environment in which the service associated with it is running. This means that your decisions about which service accounts to use are among the most critical installation decisions that you make in securing your server. The important security principle, least privilege, is what guides you here. Least privilege mandates that the account that you use for each service has the lowest set of permissions possible for the service to run and do its job. The idea there is that if you assign a service to a user that has complete control over the server, has way too many permissions, it can do anything on the server, can go across the network and do anything there. When and if an attacker gets control of that service, that attacker has a path, an avenue into abusing your server and abusing your network because the service account has far too many permissions. On the other hand, if you tightly restrict the permissions of the user account, of the service account, that each service is running under, then when an attacker gets control of that service, he or she is limited to doing what that underlying service account is able to do, which is generally not going to be good. Can do some damage, but at least the damage is limited. Can't go completely hog wild across the network. Okay, so adhere to least privilege in pretty much everything you do in software. All right, so you can use any of 4 types of Windows accounts for SQL Server services. First is a domain user account. If the SQL Server instance needs to communicate over the network, for example, to use replication, back up to network drives, send an email, whatever, it has to use an account that can access the local network. This is probably the best option for most SQL Server installations, giving you the most flexibility and control over security, again, if that service needs to communicate over the network. Then there's a local system account. This is an omnipotent account that Windows uses for most of its internal operations, with access to just about every corner of the machine. While this account is very convenient to use, you can be sure that the SQL Server instance has access to all the Windows features, all that it needs, as well as lots more. It's the worst possible choice from a security standpoint. An attacker who gains control of SQL Server would have complete access to the machine. Never use this account. My best advice of this entire course, never use this account for a Windows service, for a SQL Server service. Okay, then there's a local service account. This is a built-in Windows account that has minimal permissions that are similar to those of the users group within Windows. It can access the network, but with severe restrictions. This account could be appropriate for use with SQL Server instances that don't need to access network resources. And then there's a network service account. This is similar to the local service account, except that it accesses the network using the credentials of the computer account. This account might be usable for SQL Server, but a domain user account would give you more flexibility and security. All right, so when you specify the type of account to use for each service, the installation wizard takes care of granting to that selected account whatever permissions and privileges are required for each service. This is one of the many reasons why you need administrative privileges in order to install SQL Server. It's making some deep, substantial changes to the security configuration of the machine. But this means that you only have to create the accounts that you'll use, not configure them manually with the correct permissions and privileges. And let me tell you, this is a big benefit of more recent versions of the SQL Server installation programs, because you used to have to configure all that stuff manually. And that was a bit of a nightmare. It was error prone, and it was far too easy to introduce security problems on your server. So we have it pretty good today. Another thing you need to understand about installing SQL Server is the concept of multiple instances. One of the most powerful features of SQL Server is the ability to install multiple instances of the SQL Server database engine on a single computer. Each instance of these multiple instances of SQL Server consists of both shared and instance features, which can save resources on a single server machine. All the database objects and many server objects, including security settings, are completely contained within each instance. However, there are a few things that you need to know before you install multiple SQL Server instances. The first is that you can install one default instance and multiple named instances, or multiple named instances with no default instance. The only difference between the default and a named instance is that to access the default instance, you use only the machine name to access the instance. A named instance requires the machine name and the instance name. So that's the only difference, and that's a pretty mild difference. It's not a big deal. Now, instances other than the default instance have to be the latest version of SQL Server that you'll install on the machine. But the default instance can be SQL Server 2005 and later. So there's a few ways that you can configure a single computer. You could have a default instance of SQL Server 2005, because that doesn't have to be the latest version of SQL Server. And then you can have multiple named instances of SQL Server 2016. So if you have a named instance of SQL Server 2016, all of the named instances have to be that version. So in that scenario, only SQL Server 2016 can operate as a named instance. Then another scenario is that you could have a default instance of SQL Server 2016 with up to 49 named instances, depending on which SQL Server edition you're using. And then another scenario is you have no default instance and up to 50 named instances, depending upon which SQL Server edition that you're using. Now, the limit on the number of SQL Server 2016 instances that you can install no longer depends on the edition of the product that you're using. All the editions across the board now support and allow 50 instances. It used to be that some editions were limited to 16 editions. But as a practical matter, I don't think I've ever had more than probably 3 or 4 instances, because you really start needing lots of memory to support multiple instances, even with the shared resources. But test what you do, and you can certainly go up to the 50. Now let's talk a little bit more about multiple instance scenarios. Because implementing multiple instances of SQL Server gives you great flexibility in the kinds of SQL Server applications that you can develop and distribute. So a few examples. One is that you can continue to run existing applications on earlier versions of SQL Server side by side with a SQL Server 2016 server on the same machine at the same time. So this is a really nice scenario. If you have an existing installation of SQL Server, say 2012 or 2014, you can leave that as the default instance on the server, install SQL Server 2016 as a named instance, and then migrate your database and your applications over time. And both can be running side by side. Then another scenario is that you can run multiple instances of SQL Server on the virtual server of a SQL Server failover cluster. This is definitely an advanced technique. You need to be tuned in to the administrative features of SQL Server. But the way it works is when you install SQL Server on each computer in a cluster, you create a named instance to distinguish that installation from the other instances of SQL Server that are on the same virtual server. Okay, so to get into clustering, you can look at the failover clustering topic in SQL Server technical documentation. Another scenario is that you can maintain a separate independent SQL Server environment for development and testing on the same computer that holds your production server. This is not generally a good idea, but if resources are tight, it's doable and you can do it. You could also roll out a secured SQL Server database in a sandbox environment where administrative rights are curtailed. And then you can structure security differently for each instance that you install with different administrators. Because one of the problems in past versions of SQL Server for independent software vendors and application developers was that the system administrator in SQL Server is all-powerful. Multiple instances provide a way to curtail administration on a server instance. And then the last scenario that I'm going to talk about is that you can install software that comes bundled with the express editions of SQL Server on a machine that already has a running instance of SQL Server. Okay, so multiple instances are pretty good, but the principal drawbacks of multiple instances are that administration becomes more complex, and multiple instances consume more resources than a single installation. But it can be very convenient to have those multiple instances on a single machine. Now, there's a few more things to talk about when using named instances. Each instance of SQL Server on a machine has its own set of system and user databases. And then applications connect to each instance the same way they connect to different instances running on different computers. But they have to use a new naming convention, which is server/instance, to specify non-default instances. So if you have a default instance, it has the same name as the computer it's on, just as in older versions of SQL Server. But to connect to a named instance, a client has to use this kind of syntax, server name \instance name. And you just use that in the connection string for an application. Or if you're logging in using Management Studio, you want to go to a specific name instance, you have to specify server name \instance name. Each instance has its own database engine, supporting components and system and user databases. But only one set of client tools services all instances installed on a single machine. In other words, you only have one Management Studio, one SQL profiler, and so on. The default instance keeps the name MS SQL Server for the SQL Server instance. For named instances, the service name is changed to MS SQL $instance name, where instance name is the name of the instance, what you give it when you install the instance. This allows you to start and stop each instance independently of other instances, each service of each instance that are on the same server, and that way you can manage events and schedules separately. You can start and stop each of the instances from a single copy of the SQL Server Configuration Manager, because that's one of the shared tools, no matter how many instances that you have installed. And then you use a single copy of Management Studio to control objects in all instances on the computer or cluster, and use a single copy of the SQL Server Configuration Manager to manage the network addresses for all of the instances. And then the directory and registry structures that support each instance all use the instance name that you provide during installation to again distinguish one instance from another, because there's various things that are put into the registry and in various places in the file system. So when you install multiple instances, the computer or cluster has only one SQL Server program group and one copy of each of the SQL Server utilities that are contained within that program group.